Good morning to all of you. Today let us study about the wave optics diffraction. Diffraction due to a single slit. Okay. So here we are studying about the diffraction. Okay. See, diffraction means what? Bending of rays at the edge of an obstacle. Bending of rays from the edge of an obstacle, and it is entering into the shadow of the obstacle is called as diffraction. So what is the meaning of this one? Here suppose I am writing, so the light is coming from here and here dark shadow is okay. So what happens? It is bending. So that's why the bending of light when you are writing in the night time, okay, when you are writing in the night time, so what happens? Your shadow is falling. It is bending. It is not correct coming. It is bending. So that's why the bending of light from the edge of an obstacle and entering into the shadow of an obstacle is called as diffraction. Okay. So here definition is defined as it is defined as the bending of rays from an obstacle at the edge and entering into the shadow of an obstacle is called as diffraction. Okay. Now how it is bending, we have to learn it. Okay. So that's why the derivation was diffraction due to a single slit. Very, very important. So now we are studying about diffraction due to a single slit. So this is the definition, right? Now here diffraction due to a single slit. Now single slit means we have to take only one slit, not two slit, only one slit. So here this is the slit, single slit. Now this is named as L and this is named as M. Okay. Now this is the screen. So from here, S is a source of light passing like this. S is a source of light. Passing. Some rays are moving straight and touching the screen and meaning as points. Some rays they are touching to the obstacle at the edge like this. And here also it is touching to the obstacle. When it touches the obstacle, what happens? These rays are forming on the screen. When these rays are forming on the screen, we are naming as point P. This is a point P. Now, this is an angle theta. This is also an angle theta. This is also an angle theta. The midpoint of the L and N is midpoint. So this is named as N. Okay. Now, what you do is what I am doing is, I am drawing a perpendicular from L to L. How to draw it? So this is a perpendicular. So what is this one? This is an angle theta. Nothing but 90 degrees. So when this is angle theta, therefore this is also angle theta. Okay. The distance between the L and N, the distance between L and N is nothing but A. This means as A. Okay. So here this length is A means this opposite angle, this side is nothing but what? A sin theta. A sin theta. So here this is L and this ray is touching to the P and N is also touching to the P. So this L as well as this point I will name as Q. So this point L as well as Q, they are at the same points. But what is the difference? This NQ is nothing but extra difference, extra distance. NQ is nothing but extra distance. So what is the path difference? What is the path difference? So here what I should write? NP, this NP minus LP is equal to, what is the distance? Extra distance is what? Nothing but A sin theta. A sin theta. So for small angles, sin theta is equal to theta. So here for small angles, what is your write? Sin theta is approximately equal to theta. Therefore, what I should write? NP minus LP is equal to A into theta. Now, here, what is the path difference? NP minus LP is nothing but, what is the path difference? Nothing but what is the formula? N lambda. Okay. Similarly, what you are doing is, between the L and M, I am naming the point named as M1. Between the M and N, this is a point named as M2. So, what is the distance between M1 and M2? So, here let, what I am writing as, let M1 and M2, I am assuming as some Y. I am assuming as Y. Okay. So from here, what I can say, if I join from here to here, if I take the ray, so what is happening? What is the extra distance? What is the extra distance? So if this is Y, therefore here what I can say, we'll get the Y theta. Y theta. So from here, what I should write? M2P, path difference. M2P minus M1P is equal to Y into P. Similarly what we have studied here, the same thing. Okay. But here what happens? Between L and N, this is A distance. Total distance is A. So between L and M, what is the distance? This is A by 2. And this distance is also, M to N is also A by 2. But here, M1 and M2, what is the distance? A by 4 plus A by 4. Nothing but what? A by 2. Here, to understand what I am doing is, LM distance is A by 2. M and N distance is A by 2. Now, between M1 and M is A by 2. Okay. M and M2 is nothing but A by 2. But if I add it, what is the value can be it as? A by 4 plus A by 4. Nothing but 2A by 4. 2A by 4. Nothing but what? A by 4. So, what is the distance? Here, what I should write? M2P minus M1P is equal to Y. Y is nothing but what? A by 2 into theta. A by 2 into theta. So what is this one? This is also path difference. So the rays which are passing through the point P, it is having the path difference. It is having the path difference as well as phase difference. But the rays which are moving straight to the point C, when it is touching, what happens? It is not having the path difference. It is having zero path difference. And the rays which are touching at the center point C, it is called as a bright central maxima. It is having zero phase difference, but there is no path difference. Path difference is always zero, but it is having the phase difference. Okay. Now, here, what I mean is, so how much is the path difference? We have to calculate. We have to calculate. So there are two conditions. There are two conditions. One is the minimum as well as number two is the maximum. So first case one. First case is what? Secondary minimum. First case is secondary minimum. Secondary minimum means what is the value you should write? Theta is equal to n lambda by a. Theta is equal to n lambda by a. Okay. So what is the meaning of this one? N is equal to 1, 2, 3 and so on. Therefore, what is the should write it? Theta is equal to 1 into lambda by a. Therefore, theta is equal to lambda by a. Okay. Now, here for the path difference, what I will do? M2p minus M1p is equal to a by 2 theta. So here path difference is nothing but what? Path difference is nothing but what? What I should write? N lambda. Sorry. What I should write? M2p minus M1p is equal to a by 2 theta. Okay. So here what I should write? Path difference M2p minus M1p is equal to a by 2. Theta is nothing but what? Lambda by a. So this a cancel. Therefore, the path difference is lambda by 2. Path difference is lambda by 2. So now what is the phase difference? What is the phase difference? We have to calculate. So here what happens? This is what path difference. Now what is the phase difference? Phase difference, what is the formula? 2 pi by lambda into path difference. This is the formula. Phase difference is equal to 2 pi by lambda into phase difference. Now here what is the write? 2 pi by lambda into path difference. Path difference is what? Lambda by 2. Lambda cancel. This is 2 cancel. Therefore, the meaning is pi is equal to what? 180 degree. 180 degree means what? It is out of phase. It is out of phase. So here it is out of phase. Means what? The resultant intensity is minimum. The resultant intensity is 0. So what I should write? Resultant intensity is 0. Okay. Now here the second condition is that condition for secondary maxima. How to calculate? Okay. Now, so here what I am writing as phase 2. Phase 2 is secondary maxima. Secondary maxima. Now for secondary maxima, what is the formula we are studying here? Theta is equal to 2n plus 1 into lambda by 2a. So this is the secondary maxima formula. So here when n is equal to 1, when we keep what is the value, we get it as. So when n is equal to 1, what happens? Theta is equal to 2 into 1 plus 1 divided by lambda by 2a. So what is the value? 3 lambda by 2a. 3 lambda by 2a. So here what happens? What is the meaning of this one? 3 into lambda by 2a means 3 means what? It is divided into 3 slits. Okay. So here this is 1, 2, 3. 1, 2, 3. Right? So each one we got as lambda by 2. And here what is there? 3 lambda. So this is nothing but 1 by 3. This is also 1 by 3. And this is also 1 by 3. So this is how much difference we got it? Lambda by 2 and this lambda by 2. And this also lambda by 2. So this one as well as this one both are cancelled out. So how much intensity is present? 1 by 3rd of intensity is present. 1 by 3rd of intensity is present. Intensity of light is present at a point P. 1 by 3rd of the intensity of light is present. Okay. Now here what happens? Similarly, when n is equal to 2, then n is equal to 2. What I should write? Theta is equal to 2 n plus 1. So 2 plus 1 into lambda by 2a. That is nothing but what? 5 lambda by 2a. 5 lambda by 2a means the slit is divided into 5 times. The slit is divided into 5 times. So 5 slits, not 5 times, 5 slits. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 slits. So here what happens? This is 1 by 5. This is 1 by 5. This is also 1 by 5. This is 1 by 5. And this is also 1 by 5. 5 is 0, 1 by 5. So what is this one? This is lambda by 2 and this is what? Lambda by 2. So both will be cancelled. Okay. And next here this is lambda by 2 and lambda by 2. Both will be cancelled. So this lambda by 2 is remaining. How much intensity of light is giving? 1 by 5th of the intensity of light is present. 1 by 5th of the light intensity of light is present. So here when the source of light is passing through the screen, what is this one? Screen. From the slit the light ray is passing. So when the source of light is passing through the point C, what happens? What I said? It is a bright central maxima. It is a bright central maxima. It is not having any path difference. It is having zero phase difference. So that's why it is a bright central maxima. So bright central maxima means the intensity of light is very bright. Okay. Next, here for the condition minimum, you got 180, nothing but pi, it is 0. So therefore intensity of light is 0. But now here when n is equal to 1, how much I got it? 1 by 3rd of the intensity of light. When n is equal to 2, what is the value we got it? Here 1 by 5th of the velocity of light. So when 1 by 3rd of the velocity intensity as 1 by 5th of the intensity of light we got it. So which is greater? Which is greater? So here what we can say, 1 by 3rd of the intensity of light is greater than the 1 by 5th of the intensity of light. 1 by third is greater than the 1 by 5. Yes or no? So here this is the C point, 5 bright central max. So this is the light which is coming up to here. This is the 1 by third. Here also it is moving up to here. This is also 1 by third. Now least one is what? 1 by 5. So here what happens? 1 by 5, fifth of the intensity. Here also what happens? It is a 1 by 5th of the intensity of light. Okay, so here like this, the intensity of light is slowly decreasing like this, and it is becoming 0. So this is a point C is nothing but bright central maxima. And here is the condition for intensity minima as the condition for intensity maximum. So we will get the graph like this. Now, how to show the figure? This is a slit. This is a screen. Source of light is passing. This is a graph. The source of light is passing. So this is a bright central maxima you have seen. So how we can draw it? The graph like this. So this is a bright central maxima. Next, 1 by third intensity is like this. 1 by fifth is like this. Next, here what happens? 1 by third. Next, 1 by fifth like this, and is decreasing and so on. Like this, and so on. So this is the graph for the single slit diffraction. So here a graph showing the double slit interference pattern with envelope showing single slit diffraction. How will be the graph? So x-axis intensity. So this is the I and this is the okay. Same graph, nothing else is there. So this is the bright central maxima. Next like this. Next like this. These. So this is nothing but theta. Next here what happens? Like this and so on. So this graph, bright central maxima. So intensity is on the y-axis as well theta is on the x-axis. So this is a graph, we got it. Now what happens? I am joining this. So this is the graph showing the double slit interference pattern with envelope showing single slit diffraction. Okay. So by this is the last topic of wave optics and Polaroids, Malus law, Brewster's law, all are deleted.